Hi, class. Welcome to week 8. We've just finished a full week of studying for the midterm and basically reviewing all the concepts to this point. So now we're off to the second half of the course. And this week we're going to be looking at the normal distribution, which we've talked a lot about, but now we're going to spend some time actually looking closer at it. So this is actually one of the most important aspects of statistics because most everything we do, every test, every average or mean, median, all that stuff, it depends on having a normal distribution. And when you're not perfectly normal, things are off by a bit. And if it's just a little bit unnormal, that's okay. It's only when you have like really abnormal distributions that things really start to fall apart. But amazingly enough, in stats, as long as you tell people you've got something whacked, you can still run all the tests anyway and do your thing. So even when things are not normal, we just kind of crunch it out anyway. So we're going to be looking at central limit theorem. So it can work with non-normal distributions. And this is basically a law of large numbers. It's related anyway. And it basically, to sum that up as easily as I can, the more data you have, the closer to normal you're going to get. That's just what happens when you have lots of data. So you generally want real large sample sizes. That's always the goal. You want them as big as you can get them. So the larger your sample size, the closer that the average of your sample means and the related standard deviations will actually come to the population that your sample is representing. That's really all it breaks down to. So estimating the population standard deviation and population mean are really useful in trying to predict characteristics of populations. So remember, we're usually dealing with samples of a population rather than the whole population itself. So we want to get to as close as reality as we can. So where does this come up in nursing? You can plot the distribution of blood pressure of, say, males aged 18 to 45. And then given the normal distribution, we can easily make estimations of how far away, like the number of standard deviations something is from from the mean, that any value falls, like within that sample data. So if you've got like uh, 8 numbers, and normally you would have to have a lot more than that for any of this to apply, but let's just assume you've got 8 numbers and that they are 2, 3, 4, 5, 6, 7, 8, 9. If I want to know how far of a number 4 is from the average, we can actually compute a z-score to tell that, because the z-score is nothing more than like the number of standard deviations you are from the mean. So, and that kind of tells you, where in a population or where in a sample your patient is from when you measure a blood pressure. So it's actually pretty cool. So that's where we're going this week. You've only got 3 homework assignments, which is nice. It's kind of an easy way to kind of break into things. I'll be posting lots of help in discussion as I always do. I try and post something every day. So tune into discussion this week, and I'll share some resources and stuff. And yeah, that's kind of where we're at. So everyone take care, and I'll talk to y'all later.